Okay, let's try one last example for this lesson. Lately, an epidemic of the dreaded math virus has been sweeping the nation. Fortunately, there are tests to determine who has been infected and who should be hidden away from society. But as with pretty much all medical diagnostic tests, this test is not infallible. Some key points. Recent estimates are that about 0.5%, so about 0.5% of the American public carries the dreaded math virus. That is, the probability of math is 0.005. If a person does not carry the dreaded math virus, then the test gives a negative result about 90% of the time. That is, the probability you'll get a negative result given you don't have the math virus is 90%. On the other hand, if someone actually does have the virus, experts estimate that the test gives a positive result about 99% of the time. That is, the probability of getting a positive test, given that you do actually have the math virus, is 99%. So suppose that someone tells you they have been tested positive. Given this information, how likely is it the person actually carries the dreaded math virus? So take a moment and think about it. What do you say? 50%, 70%, higher, maybe even 90%? Well, how can we go about finding this? So we basically want the reverse of this last bullet point. Instead of probability of positive given that they're math, we want to find the probability that they have the virus given that they tested positive. So what happens if we reverse these two? Well, one way you can figure this out is to create a table. On the one hand, you have whether or not they have the virus or don't have the virus, so math free, and whether or not they tested positive or negative. So we have our contingency table. And for this case, we start with a total, the overall total. I put 20,000 here. You can put any number you want. The number itself, I put 20,000 for convenience, but any number will work. Oftentimes, you might just start with the number 1. That way, anything you see in the table would be more of a percent. But I'll pick 20,000. Again, I just chose it because it makes the numbers come out nicely. Any number works. Now let's start with this first point. Recent estimates are that 0.5% of the American public carries this virus. That is, the probability that they have the virus is 0.005. So if I go 0.005 times the total number of people, the 20,000, I find 100 people. So the total, those who have the math virus, there's 100 people total. And then we can get this number here below it by subtracting. The total number of people who don't have the virus then would be 20,000 minus 100, or 19,900. Okay, so we got the table partially filled out. So based on this 20,000 people, 100 will have the virus, the other 19,900 will not. Now suppose someone does not have the virus. We are told then that they'll test negative 90% of the time. So we have 19,900 people who don't have the virus, and we want to figure out 90%. So if I go 90% times 19,910, I get 17,910. So out of those who tested, who don't have the virus, 17,910 will test negative. And then by subtraction, if the 17,910 test negative, that means 1,990 people don't have the virus but test positive anyway. All right, now let's go to the next point. If a person actually carries a dreaded virus, experts estimate that the person will test positive 99% of the time. So if we have 100 people who test positive, 99% of that will be 99. That leaves 1 who has the virus but tests negative. And then we can get their totals down here. 99 plus 1,990 is 2,089. 1 plus 17,910 is 17,911. Now we have our table filled out. So the question is, the information can be simplified by the following table. Chosen again, 20,000 was chosen just to make the numbers nice. Any number, this overall total here could have been any number. Of course, if you try a different number, then that's going to change these other numbers. But you can start with any number you want. Now the question is, we want to find the probability they had the virus given they tested positive. So looking at this, 2,089 people, if I'm looking at this table here, 2,089 tested positive. Only 99 of them actually have the virus. So the probability that they have the virus given they tested positive is 99 out of 2,089, which is less than 5%. So that's considerably less than the 50, 60, 70% that I might have guessed at the beginning of this problem. So someone who tests positive should probably not panic too much. Only 5% of those testing positive actually have the virus.